So today we're going to whistle through probability, single lesson for year 12 probability. There is more probability in the second year, but it's not super hard. And I normally don't do any probability at all in the first year because there's not a great deal of new content. But just to make sure, and I'm hoping that having gone through the upload stuff, you're just going to say, oh yeah, no, I know that, and I know that, and I know that. So this question here, just a reminder that we're dealing with area of bars which are equal to the frequency, and you had the frequency density axis labelled. So it was a bit fiddly to work out the areas, but they tell you that the total area is 70. So it's perhaps made a little bit easier. So has a mass more than 5, so you just have to work out the area of these two bars. So we had 1 times 24 and 2 times 4. So that's, oh hang on, 1 times 24 and 2 times 4, 2 times 4 is 8, yeah, so that gives you 32. 32 out of 70, which is 16 out of 35. And then estimate the probability that the cat chosen has a mass of less than 6.5. So you basically had to say, well, we've got here 8. So I'm basically going to lop off a quarter, which would leave me with 6 cats here. Now it doesn't say more than, it says less than. So we're dealing with 64 cats that are less than 64 out of 70, 32 out of 35. And the assumption there, although it doesn't ask about the assumption is that in that last group, that 6 to 8 group, those 8 cats, their masses are distributed evenly amongst that range. I'm not going to do any more about histograms. I am going to talk about Venn diagrams firstly, and then tree diagrams. And very, very briefly, because we met all of those things at GCSE. Sorry, I can't get the smartboard to work with my laptop, so forgive me for squat down here. So, firstly, question 6. A reminder that we've got 2 sorts of Venn diagrams that we deal with. We've got those where, well actually I suppose 3 sorts really. There are the ones at GCSE which you don't really see at A-level, where you write individual things in here. So people from Coomartin, people from, no you can't put Coomartin and Ilfracombe overlapping. I don't know, you write individual elements in the thing. Don't see any of those. The 2 that we see at A-level are the ones where you have the number of things, the number of elements in each section written. In this case, the probability of being in each section is written. And because of that, we know that all of my values need to add up to 1. Because you are certainly going to fit somewhere in this diagram, and we know the probability of something that's certain is 1. So we've got A is someone does archery, B is someone does badminton, C is someone who does croquet. We're told the probability that someone takes archery is 0.45. You've got to find the missing value. So just see if you can work out the missing value. That isn't on the sheet, so I'm hoping you can see it. This isn't me answering the question, by the way, this is me preparing for the next bit. So my middle circle needs to add up to 0.45. Which is why x has to be 0.15, and then all of my probabilities have to add up to 1, and so that's why y is also 0.15. I'm sorry if you're at home That was page 75, question 6. Page 75, question 6. Okay, so probably the only new thing in Year 12 probability, apart from the fact that questions perhaps get a little bit harder, is the idea of proving when two events are independent. Okay, so if we've got two things where the Venn diagram has no overlap at all, we're dealing with two things that don't happen at the same time. There's no overlap. And we call that mutually exclusive. So whatever A and B are, they are mutually exclusive. They can't happen at the same time for whatever reason. A and C are mutually exclusive. I don't know why someone who does archery wouldn't want to do croquet. Perhaps they were both on at the same time. Perhaps they were both on a Monday afternoon, whereas badminton was on a Tuesday afternoon, so you could do that along with either of those. If there is an overlap, then clearly those two events can happen at the same time, so they are not mutually exclusive. But are they independent? Now this is something different. Two events are independent if one doesn't affect the other. Okay? So, for example, it is Monday. No, sorry, that's a bad example. Okay. Let event A be, it is raining. Okay? Let event A be, it is raining. Let event B be, EastEnders is on the telly. All right? Now those two things can happen together. I don't know if EastEnders is on which days, but you can have a day where it is raining and EastEnders is on the telly. So they are not mutually exclusive. Those two events, though, are definitely independent. It's not more likely to rain on the days when EastEnders is on. And if it's raining, it's not more likely to be EastEnders on the telly. Those two events are independent. It is raining and your bus being late, well, you could argue that those two things perhaps are not independent, because if you've got a bit of a shonky bus company that maybe their engines don't run very well in the wet, then if it's raining, maybe there is a chance that the bus is going to be late. So those two events, I would suggest, are not independent. You can't tell from a Venn diagram if events are independent or not. Sorry, well, there is a way, we're going to look at it, but you can't tell by just looking. The fact there's an overlap there means those two events can happen at the same time, but we can't tell if they're independent by just looking. We can't tell instead, we have this rule, and this is, I suggest to you, the only sort of new rule. A and B are independent if the probability of A, that's A happening on its own, probability of it raining, probability of EastEnders being on, multiplied by the probability of B is the same as the overlap. That's the only way we can test if two events are independent. And that's really the only new bit of content that gets introduced in Year 12 probability, apart from the fact that some of the tree diagrams get a little bit harder. So let's look at two examples, one where we get a tree diagram with numbers, and one where we get a tree diagram with probability. Okay. So here we are on, for those at home, page 76, example 7. Page 76, example 7. So we're not given probabilities here, we are instead given the number of students who fall into one of three categories. They like programme A, programme B, and programme C on the telly. A and C are mutually exclusive. Maybe they're on at the same time on different channels. Well, of course, that doesn't really apply these days, but anyway, there we go. So the probability will be how many students we're dealing with out of a total. Okay, so just see if you can have a go at those two questions. You probably need to start by working out how many students there are in total. Part B is the key part. It uses this rule here. So it's our first sort of look at this rule here. Yes, sir.
Can I quickly go grab my phone and lift upstairs?
Yeah, sure. So there's 30 students, and 26 of them are watch B or C or both. All right, everyone apart from 4 of them. Here's the key. If these two events, A and B, are independent, the probability of A, which is 7 out of 30, 7 of the students out of 30 watched A, multiplied by the probability of B, which is 19 out of 30, will equal the overlap, 4 out of 30. Now, so I get my calculator out and I do the sum on the left-hand side. Have we? Has anyone done that and checked? Which do we go for it, Arthur? Does 7 over 30 times 19 out of 30 give you 4 over 30? Doesn't look likely to me, but. So I'm going to use that notation. So they are not independent. Simple as that. Simple as that. Now, as to why that is true, did upload go into why it's true? So there is, okay, so there is a reason for that, which, forgive me, I'm not going to go into now, but if upload went into it, that's brilliant. That's brilliant. Okay, page 77, page 77, question 6. So here we've got a situation where we have probabilities rather than the number of people. A little bit quicker, perhaps. So see if you can answer this question. Firstly, work out the missing value. We know they have to add up to 1. And then you've got to say whether A liked pizza, A is like pasta, and B is like pizza, whether they are independent. The use of the word write down, or sorry, it's 2 words, the use of the phrase write down implies it's really obvious. It should be really obvious. There is nothing mysterious going on. Honestly, that door can drive me nuts. Sure.
May I get started?
Of course. I can borrow your calculator while you're there. We've got 0.25, which is what you needed to make everything add up to 1. So that means the probability of A is 0.65, and the probability of B is 0.55. And if you multiply those two together, you do not get 0.25, so they are not independent. And really that is all there is to it. So on the sheet, and for those at home, this sheet has got the questions from page 77, starting at question 7, and then question 10 is on the next page. Just have a go at those 4 questions quickly. They're all about Venn diagrams, and they all involve, amongst other stuff, the question, are these events independent? Sorry, they're on page 81, the questions. So it's 7, 8, 9 and 10 on page 81. Okay, so Venn diagrams, first part of what I wanted to do today. Tree diagrams, second part. So I would say that this is a pretty standard GCSE higher level tree diagram. You've got the first hole. Scoring par means getting, or under means getting it in the number of shots you should do, or less, which is good news. More than that is bad news, so I can have par or not par. And then you've got the second hole, your second set of branches. But notice that it throws in independent again. So the same rule that we've used with Venn diagrams, we can use for tree diagrams. So go on, have a go at setting up a tree diagram and filling in as much as you can from what you're given. There's a clue in part B that indicates you haven't actually got to do a calculation. I mean, we can do the calculation, but it says state. State whether the event scores par on the first hole and scores par on the second hole are independent. Well, clearly they're not, because these probabilities are different to these probabilities. So what happens with the first hole does affect. So that's a sort of a common sense answer. And we can prove we can prove it. So if I work out my probabilities at the end, so probability he pars both is 0.56. I know it's par or under. That's 0.14, that's 0.12, and that's 0.18. So the probability that he pars the second hole, well, that's those two added together. So that's 0.68. And the probability he pars the first hole, 0.7. The probability that he pars both holes is 0.56. And that times that does not. But you don't need to do that calculation in this case because it is obvious that they're not independent. Was that a puzzle look, Sean? Okay. And then the last one, the probability he scores par or under on only one hole. Well, that's these two outcomes, isn't it? That's either the first or the first and not on the second, or not on the first and the second. So that's 0.26. So the only difference between that, between a GCSE higher question and this is just this mention of independence and an understanding of what it means and how we can prove that two events are independent. Okay, so the question on the sheet, for those at home, I think that's from the mixed exercise, so let me just double check. It is, yes. So we're going to finish this whiz through probability by looking at question 80, page 82, sorry, question 12, which for those here is at the bottom of the sheet. I'm going to say nothing to start with. I'm interested to see how you're going to go about drawing your tree diagram. It's not super straightforward, but I think it's worth giving you a chance to have a think about it. I'll draw my tree diagram like this. So we've got 0.16, 0.50, and 0. I think it was the rest, so that's 666. So this is 0.34. And so we've got for A, 4% are defective, so I put that as 96%, okay, and 4% not, and similarly there, and similarly there. So that's that one, and produced by machine B and defective, so that's this branch here, so that's 0.5 times 0.03, which is 0.015. And defective, well, that's the three defective branches added together. So we've got that one, and we've got which is, I don't know, I've got the calculator, but there we go. If you add those three together, that will give you your answer. 0.0452. 0.0452. I note they did their defective and not defective the other way around. It makes no difference. The last thing that I wanted just to point out was a bit of notation that cropped up at GCSE, and I just want to make sure you remember it. It's the use of the word given, or phrase given that. So in this question here, we've got two tokens taken out of a bag, and we're asked to write down the probability that the third token is yellow, given that the first two are yellow. Now, I'm not going to bother drawing a tree diagram to answer this question, because A, it's really complicated, and B, it's something I can do in my head. So the probability that the first one is yellow is 6 out of 13, so that would be my first branch. And then the second yellow, well, if I've taken one out, there's only 12 left, and I've taken a yellow out, so there's only 5 of them left. So the probability that the third token is yellow, given that the first two, remember that given that tells us that we're already here. Okay? So it's not asking what's the probability that the first 3 tokens are yellow. That would be this multiplied by this next number. Given that means this has already happened, we're only interested in what comes after. So that would be 4 out of 11. Okay? Given that, and the notation we used for given that was well, I tend to do it like that, but I think it tends to look like that. So in this case, we were asked, what's the probability that you get a third yellow, given that first 2 were yellow? Okay, and the bar notation, whether it's like that or like that, means the same thing. So given that means we're already at a particular point, we're only interested in what happens after that. And that's it really, that's it. What we'll do is tomorrow we'll do a past paper question just to start us off based on this, but really that's all I've got to do. Does anyone think that Uplearn, because I haven't gone through the Uplearn stuff, was there anything on Uplearn which confused people that you think you'd rather I did a lesson on as well? Speak now or we move on. Okay, so once we've done that starter question tomorrow, we will move on to these hybrid lessons where the first part will be Year 12 revision, the second part will be Year 13 content.
Oh, are you going back and forth?